Well, hello scrappers, Mike here. Welcome back to my channel. And today, I've promised this in the past, and it's taken a lot of R&D, but I think I'm finally getting there, okay? Today we're going to try recovering tin from e-waste, because I get a lot of requests for that from people. They want to know how to recover tin from e-waste, because apparently tin has gotten quite valuable. And they're like, well, you keep talking about recovering copper, but tin's as valuable or more valuable than copper. When are we going to show us how to recover the tin? So today we're going to start working on that. I think this very dirty beaker, which has suffered multiple baked-on boilovers, which I can't seem to get cleaned off. And we're going to put some circuit boards in here covered with tin. And what kind of circuit boards, you ask? Well, ram stick circuit boards, which I don't know if you can see down there because it's kind of dark. But these are circuit boards that I depopulated with my rotary depopulator in a previous video. I'll put a link to that video. So there were 11 plus pounds of ram sticks that I depopulated. And in that video, I actually put a little teaser to this because I was doing some R&D work on getting the tin off these boards, because I got these from my friend Rick in Georgia. He had already cut off the gold fingers for himself. He sent the boards to me. I have depopulated the chips off of them. So what we got left here basically is just circuit boards covered with tin solder where the chips were. That one got a little overcooked in the depopulator, but yeah. So there's a lot of tin here that we're going to try and recover. And I'll show you how I'm doing it, okay? Zoom back out. And what I'm going to do is I'm going to start filling up this beaker with these circuit boards. Try and get as many of them in here as I can. Take a little packing. Might leave this overcooked one out. I don't know what we might boil out of it. So let's see if I can get them down in here a little better. A little space between them would be nice. All right. So there we go. So these take up right around they're coming up right around to the 1800 milliliter mark. So I'm going to fill this thing up about halfway, maybe a little less than halfway with water. We'll do about halfway. 900 milliliters with water, and the rest with muriatic acid. And look at the fizzing. Look at that. Look at it go already. And that's only, I've diluted the acid by 50% here, but look at the reaction we're getting. So I'm going to put this in a fume hood and put it on a little heat. Not a whole lot of heat. I don't want to boil it, but the heat will speed up the reaction, and the muriatic acid is going to dissolve the tin off of these circuit boards. All right, so let's do that. Let me get this in the fume hood. All right, so we're in the fume hood. Let me put a little heat to it. Get the fume hood going, because we're going to start producing. Well, the stuff that's bubbling up is hydrogen gas, so I'm not too worried about that. But it's going to bring a lot of hydrogen chloride out with it, especially once we heat this up. The hydrogen chloride is going to start bubbling off. So, we'll heat this up, and we'll just let this cook for a while. A few hours, however long it takes until it looks like the solder's all dissolved. And what we'll do then probably is transfer the liquid to another beaker and do another load, because I got a feeling the acid will still be active to do another load. From my small scale testing, that seems to be the way it works. Okay, so we'll just let this cook, and we'll be back when it looks like it's done. Okay, this has had a chance to warm up a little bit, and we've got a really strong reaction going on in there. Lots of bubbling. Yep, that tin is going into solution. So we're just going to let this cook until it looks like the reaction's pretty much done. All right, so this has been going for a couple hours now, and it looks like the reaction is essentially done. The bubbling is a whole lot less. Let me move the camera a bit, and hopefully I can do this without blocking your view too badly. But what I'm going to do is I'm going to transfer the liquid from this beaker into this beaker, which has another batch of ram sticks in it. That drained for a minute. Oh yeah, that is still highly active over there. It's bubbling like crazy in there. So yeah, I'll get some heat on that, and we will continue the process of dissolving tin off of some more ram sticks. I want to make sure we have enough tin to actually get a decent sample here for the next step in the process. Okay, let me swap these. This one on the heat, lid on it, and we'll let that one cook for a while. All right, so I'll be back when it looks like that one is done. So I know the next question I'm going to get is, what do you do with the boards after you extract the tin from them? And well, they're in my garbage can. And well, here's the thing. Some of you are going to complain about that. The scrapyard near me will buy depopulated boards, but I don't think they're going to buy them after they've been dumped in the acid because they're just too ugly. They won't buy boards if they've been like depopulated in fire or something like that. And these look pretty ugly after going through the acid, so I don't think they're going to buy them. I mean, it depends on who's running the scale. Sometimes some of the employees are a lot more liberal about what they'll buy than the old man owner. If he's running the scale, he's really picky. So you never know who you're going to get when you go over there. So, and really, just a couple of pounds, they don't pay that much for depopulated boards. So I'm just going to throw them out, and I'm not really out much. I got these things for free, so I'm not really out anything. And I've got the tin, and I got the chips off of them, and Rick got the gold fingers off of them. So we've already got, all the low-hanging fruit of the value that's in these things. Somebody's going to have to grind these up and separate the copper out. Somebody like Jason over at MBMM could do that, but I'm not set up for it, and I don't think my scrapyard will buy them. So into the garbage they go. All right, let's get back to business here. Well, there's a lot of life left in that acid. This is really going gangbusters over here on the second batch. So we'll just let this go for the next few hours and see what it looks like. All right, well, it's been a few hours again, and it looks like the activity has slowed down. So one more time, gonna pour this off onto some fresh ram sticks. Uh-oh. And yeah, it looks like we're starting to get some activity, although it's definitely not as fast as it was with the first two batches. I would say this acid is just about spent. So I'm going to let that drain, and then I'll swap them out and get that on the heat again. And we'll let this go for a couple hours, and I'll probably shut it down, let it cool down. Tomorrow we will deal with it, okay? And I think by then we should have plenty of tin in solution to try and recover. Alrighty, it's the next morning, so this is nice and cool. And I think the acid's pretty much spent. So once again, we're going to decant this off. Yeah, it's got a lot of particulates in it. Pretty nasty looking at this point. So I think we need to filter this before we move on. I'm just going to let this sit here and drain for a bit. Get as much of that liquid off of there as we can. Then I'll get set up for filtration. All right, before we filter this stuff, I want to do something else. I'm going to add some sulfuric acid to it. And anybody out there guess the reason for why I might want to add some sulfuric acid to it? Yes, whoever said that, you're right. Because there's probably lead in here. Lead is a component of a lot of solders. And look at that, it's going milky. So we are probably precipitating lead sulfate. So we want to get rid of that. We put in, that's about 12 milliliters. Maybe I'll put in one more pipette, make it 15. All right. Stir that up good. Yeah, that definitely went kind of milky. So I think we are precipitating some lead as lead sulfate out of there. So I'll let this sit and react for a bit and settle, and then we'll filter it. And hopefully we'll get something nice and clean and that's mostly just purely tin in solution. All right? Yeah, it's definitely gone milky. I'll just let this settle for a while before I do anything else with it. All right, this has had a chance to settle. It's not perfectly clear, but well, we'll start trying to filter it. I'm just going to give it a gravity filtration. I'm not going to get too elaborate over here unless this doesn't want to filter, in which case I'll get the vacuum filtration set up out. But I'm really not in a big hurry. Oh, wow, there's a lot of lead sulfate in the bottom of this, it looks like. So I think putting some sulfuric acid in there was a good idea. Yeah, there's a lot of white powder in there suddenly when before there was just some black particulates. Also, I've got quite the bathtub ring around my beakers from cooking those ram sticks in muriatic acid. I have tried to scrub it off and it ain't coming. So I might do my usual trick of boiling a little bit of aqua regia in these beakers and see if that cleans it up. But yeah, I'm still using the beakers, so I'll wait till this process is done, then I'll try and clean them up and make them sparkly and nice for the next video I do. Oh, this is filtered nice. So okay, so I'm going to go ahead and filter this stuff, and we'll get a nice clean precipitate, and then we'll move on from there to the next step. All right, I don't know if you can see that layer of white stuff down there. See that layer of white stuff? That's lead sulfate. So yeah, a little sulfuric acid, not a bad idea. Hopefully we're getting some nice, pure. You know what we made here, don't you? This is stannous chloride solution, basically. Um, I could bottle some of it and use it for testing gold solutions, although it'd go bad pretty quick, I'm sure, but still. So that's basically what we've got here. All right, that looks pretty good. Let me get this in the fume hood and we'll move on to the next step in the process. All right, for the next step, I want to evaporate this down. All right, we're right about at 1,400 milliliters in here. I want to evaporate this down to 700 or maybe even a little less. Just, I want to concentrate the tin in there, plus I want to boil off any remaining hydrogen chloride. So this is going to take a little while, heat up and boil off, but I think it's an important step, so we're going to do it. So we'll be back when we've reduced this some. It's just like a cooking show. We've got to reduce the sauce a little bit before we move on to glazing the bird with it. Okay? Almost there. Almost there. I'm just going to let it go a little while longer and then shut it down and let it cool off. It needs to be cool for the next step. All right, so since I was too lazy to come out in the driving rain and shut off the heat on this, this is reduced a little bit more than I planned, but I think it's fine. We're down to what, 600 milliliters. Fine, that's fine. I just wanted to concentrate this stuff, get rid of some of the lingering hydrogen chloride, and make some room in the beaker. That's important for the next step. So let's go over to the bench over here and get to work on the next step. All right, so you're wondering what's the next step. Well, we've got a very concentrated solution of stannous chloride there in the fume hood. Stannous chloride is very soluble in water. As you can see, I've reduced the volume of the liquid by close to 3 times, and we still didn't get any kind of precipitate, didn't get any kind of crystals growing out of it. So stannous chloride is very soluble in water. We need to convert that stannous chloride into a tin chemical that is not soluble in water. And I'm going for tin hydroxide. So we're going to do that. We're going to use some lye, some sodium hydroxide. Going to mix up a very concentrated solution here of sodium hydroxide because we've got to neutralize any remaining hydrochloric acid in there. And of course, we've got to convert the stannous chloride into tin hydroxide. So we're going to make up a fairly stiff batch of this stuff. But we have to be careful. We have to be careful. When we have to be careful in lots of different ways. The lye here is very dangerous. To deal with. It's going to get very hot as I dissolve this in the liquid here. It can actually get hot enough that it can boil and spatter on you, so you got to be careful about that. Put it in small increments with lots of stirring. But we have to be careful in another way, because tin hydroxide and tin oxide are strange chemicals. They are soluble in both acidic solutions and caustic solutions. But around neutral, they are not all that soluble at all, and they'll come out of solution. And that's what we want. We want them to come out of solution. So what we don't want to do is when we're adding our lye solution here to our stannous chloride solution, we don't want to overshoot, basically, and go far to the caustic, well above 7 on pH. Because the tin hydroxide we create on the way to a little above 7 will just go mostly back into solution as we go way above 7. So we don't want that. So we have to be careful. I've got my pH testing papers out here, and we will test the pH as we go to make sure we don't overshoot by too much. I think it does need to be a little above 7. I'm thinking like 8 or 9 tops, and we're good. But if you go way above 7, and I'm speaking from experience here, most of your tin hydroxide goes back into solution, and the solution turns a nasty, opaque black. So we don't want that. So this has gotten quite hot. Whoa, quite hot. Just dissolving the lye in it. All right. And it was important to cool that liquid in the fume hood because it was already nearly at boiling. And when I put this stuff in it, there's going to be an exothermic reaction. It's going to get even hotter. So there would have been a boil over most likely. So I'm actually going to let this cool down a little bit before putting it in that stuff, just to make sure that we don't get so hot that we get a boil over or a bubble up or spitting or fizzing or whatever. So we'll just let this cool off, and then we'll add it and see what happens. All right, the lye solution's had a chance to cool down. I'm hoping I can show you this reaction without blocking it too badly. And you can see what goes on. Now I do have some strips of litmus paper ready to go so I can test the pH from time to time. But in it goes. Look, you see a precipitate forming, but it immediately goes back into solution. But as we bring the pH up, that precipitate should remain in there. Now we started out, I didn't show you what the pH was when we started. Let me mix this up a little bit and we'll measure it right now. Oh, and yeah, it's, whoo, that gets hot. That is quite the exothermic reaction right there. So we're still quite acidic. So we're going to put some more of this in. That's why the precipitate keeps going back into solution. Now I have overshot in the past, so I'm going to be very careful here and try not to badly overshoot. Still acidic. Now you can see more of a fluffy precipitate forming, but it's still going back into solution. It's turning purple, which tin complexes will. Still acidic. But some of this precipitate seems to be lingering in there, so that's good. So we're getting there. Look at that. See that precipitate now? I hope that's showing up good. That's our tin hydroxide that we want to precipitate out. It's still going back into solution, so I think we're probably still a little acidic. This is why I mixed up so much lye solution. Yeah, we're still a little acidic. But, you know, it's lingering longer. I might have to mix up some more lye solution. This is more acidic than I thought. I might very well have to mix up some more lye solution because everything seems to be going back into solution here. Now, yeah. Yeah, it's still acidic. Now, like I said, I'm probably going to have to mix up some more lye solution. What I forgot to mention was you don't have to use lye. You can use just about any base to do this, but you see how much lye I'm having to use. So, you know, my initial experiments, I used ammonia, which worked really well. You just took a whole lot of ammonia. I kept having to transfer everything into bigger and bigger beakers. So keep that in mind. Yeah, I'm going to have to mix up some more lye solution because apparently this is still really acidic in here. Yeah, still really acidic. Okay, so let me mix up some more lye solution, and this has gotten, whoa, probably really close to boiling, so we'll let that cool off a bit, and while I mix up some more lye solution. All right, I've mixed up some more lye solution. This is where the process starts getting a little bit dangerous because the lye solution is quite hot. This stuff's already quite hot. We could have a boil over. But we are getting very, very close, I think. Look at all that. Yeah, look at all that. Okay, there's our tin hydroxide. Finally, looks like it's coming out of solution. Is it going to stay out of solution is the question. This is still slightly acidic. I'm going to put a bit more in. Being very cautious now not to overlie it. Yeah, look at it all coming out of solution now. There we go. It looks like a vanilla milkshake, but I wouldn't want to drink it. Let me get another piece of litmus here. Now, I said before that my initial experiments I used ammonia, but it took a whole lot of ammonia. I'll tell you what, though, ammonia does come in handy if you want to just tweak it a little bit rather than putting in more of this stuff. But I do want to get it slightly above 7. Oh, well, I think we're above 7 by quite a bit. I think that last addition was a bit much. What I might do, put just a bit of muriatic acid in there to try and bring the pH back down just a bit. Just to make sure that we get all of our tin out of solution. And it's not hanging out there in solution because we've got the pH too high or too low. Oh yeah, that's still pretty high. That last additional lye was just over the top. Fortunately, it did not turn a nasty opaque black, which it will do if you put way too much lye in there. And then almost all your tin hydroxide goes back into solution. Bringing the pH back down like I'm doing now with a little bit of hydrochloric acid will get the hydroxide back out of solution. Oh, we are right about neutral. That is right about neutral. You know what? I'm probably just going to leave well enough alone and quit messing with it before I screw up. And we're just going to let that sit and settle. It is hot as all get out, let me tell you. That is just below boiling probably. But we'll just let this sit and settle, and we should see the tin hydroxide over time, hopefully, settle to the bottom of the beaker if it's not too light and fluffy. Sometimes it is pretty light and fluffy and takes a long time to settle. But anyway, we'll filter this eventually and capture all this on a filter. But we have successfully converted our highly soluble stannous chloride into insoluble tin hydroxide, and it will settle out over time. So we'll just let that go on, just let this cool off and settle. Oh, it's just been a couple of minutes, and look, it's settling. This stuff's got sort of a cottage cheesy consistency to it. Good, it's not so light and fluffy as I've had sometimes. It's only been a couple minutes, just long enough for me to bottle up my leftover sodium hydroxide solution here for the future use. And yeah, I think probably give this an hour or so, hour or 2 hours, and it'll settle nicely. And then can filter it, capture all this lovely tin hydroxide and get rid of the water. Okay, so we'll just let it continue to cool and settle. Well, this stuff has sat for a couple hours while I've been working on other stuff, and yeah, it's settling nicely. So it's getting late in the day. I think I'll just let this sit till tomorrow, and we'll get out the filtration apparatus, and we will filter all that tin hydroxide out of the liquid, and then figure out what to do with it next. All right, let's filter this stuff. Try and pour the liquid off first so we don't plug up the filter too bad right off, because I'm going to want to dry this stuff out as much as I can in the filter here. You don't want to plug it up right off. So once all this liquid goes through, I'll get the solids in there. More liquid here. Trying to leave the solids behind. Okay. This liquid is a waste product. It probably pretty salty, I would imagine. Probably has a lot of sodium chloride in it, but it should be otherwise pretty harmless because any heavy metals in it are now in here. They've been precipitated out, so I would not hesitate to dump this liquid down the drain. Okay, so this is going to take quite a while because you can see how it's slowed down now that I got the solids in there. So we're going to have to dehydrate these solids a little bit, get the rest of them in, and then I'm just going to let this run for maybe an hour or two to dry out these solids up in the filter. Start the dehydration process because before we can do anything with them, we really need to dry these out. So maybe I can get the rest of it in now. I want to overtop the filter. Oh, look at the bathtub ring on that beaker. And we'll see if it wipes out. All right. So, you're not going to miss much except a few hours of this running and slowly dehydrating all that tin hydroxide we've got up there in the filter. And I'll give you a look at it once we're done and show you what it looks like. Well, I'll give you a quick look at it now, sort of a before and after. Yeah, so here's the before. And I'll give you a look at it once we get all this liquid out of it and we're just left with solids. Alright, so this is what it looks like now that we've sucked a lot of the water out of it. The filter's pulling in on it. But it's still dripping, so we still got water coming out. So I'm still going to let this run for quite a while and dehydrate this stuff as much as possible. Alright, I think I've got this stuff about as dry as I can here with the vacuum filtration. I'm going to take it out and put it down here in this dish and for some further drying. Alright, so let me get this out of here into this dish. There we go. There's our tin. I'm going to do with it next is put it in the fume hood over low heat and continue drying it out. Do I want to scrape it off of the filter first? Nah. It'll be easier to get off the filter when it's dry and powdery. So we'll just put it over low heat in the fume hood. Okay, so we'll just let that dry. Got to be good and dry for the next step. It's shrinking up a lot as it dries. By the time it's good and dry, we're not going to have nearly as much material here as it looked like we had to start with. But it's still pretty wet on top, so it's got a lot of drying left to go. Alright, it's actually the next day. And this is all dried out nicely. Oh, this filter's hard as a rock too, and I can just kind of scrape the tin hydroxide off of it. Now it's gone dark in color, some of it, and I think what we're doing here is converting some of the tin hydroxide to tin oxide, which is not an issue because we really need to do that anyway. Because all of the smelting information I have seen on tin has dealt with the oxide, not the hydroxide. But it's pretty easy, apparently, to turn the hydroxide into oxide. Basically, just roast it a little bit in air. So, yeah. So, this is still pretty hot. I accidentally left it on overnight. I thought it was done yesterday afternoon. I thought I turned it off, but I didn't, I guess. So, I'm going to let this cool down a little bit. And then we're going to pull this out of here and grind this up into a powder. for the next step, because these chunks I don't think are going to work so good for the next step. All right, so let's grind this stuff up. Of course, I'm doing this on a fairly small scale here, so we'll just use my mortar and pestle. Doing this on a bigger scale, I want to use a coffee grinder or even my mighty mill, maybe. Actually, running this stuff through the mighty mill, not such a bad idea, but I've already got started here, so we'll just keep this up. Get this ground up. Fortunately, it's not too hard. That's probably good enough right there. Yeah. Well, in the time it'd take me to get the mighty mill out and make sure the battery's got a good battery on it, well, I'll probably have this done. So, you go ahead and keep at it. And we're back when I am done. Alright, so it's time to see just how much tin hydroxide we've got here. It's probably a mixture of oxide and hydroxide, so I hope you can read that. I mean, we're kind of got some reflections out here, and the scale's dancing around a little bit due to the wind. Wind is kind of my nemesis out here, working outdoors sometimes. Sometimes it feels good, like today. I feel like the 7th level of hell out here, even though it's kind of warm because there's a bit of a breeze. 58.34 grams. I hope you can see that. 58.34 grams. So yeah, I did this on a pretty small scale. Did it in beakers. But, you know, this could be scaled up a whole lot. I could see, you know, doing this in drums of muriatic acid, maybe, you know, poly drums, and just sticking your depopulated boards in there. Big boards, not the little ones like I always use them, but the big boards. And, you know, just keeping that up until that acid is spent. I mean, it's going to take a lot of base, like sodium hydroxide or something, to neutralize that acidic tin chloride mixture, but you could wind up with a whole lot more tin oxide than this if you scale up. So that's a possibility. So next, we need to convert this into tin metal. And, well, there's a couple steps left to be done for that, so we're going to pick up in the next video. So I hope you found this video interesting, educational, informative, inspirational, whatever. If so, give it a like, give it a thumbs up, and subscribe to see that future video that's coming out on this. And a lot of my other videos are coming out too, including a series I think you're going to find really interesting that I'm working on. So yeah, subscribe for those. And check out my 2 other channels, Electric Geek 64, where all my electronics and retro computing stuff happens, and Mike's Lapidarian Fossils, where all of my rock hounding, rock cutting, fossil hunting, fossil prep stuff happens. So check those out. Please like, subscribe, and comment there as well as here. And I will see you in the next video. Thanks for watching this one. Bye.